Hello friends, welcome back to my channel. Today we are going to see the heterocyclic compound. First of all, we should know what is the heterocyclic compound. Heterocyclic compounds are the carbocyclic compounds or carbon containing compounds in which one of the carbon is replaced with the heteroatom. Considering the carbocyclic compounds, one of the carbon is replaced with the heteroatom such as oxygen, nitrogen or sulfur. It is not necessary only one carbon, we can replace two or three carbon also with the heteroatom. In generally, there is oxygen, nitrogen, and sulfur containing hetero compounds are used, but sometimes phosphorus, boron, or silicon base bearing heteroatoms, heterocyclic compounds are also present. Traditional or most famous Suzuki coupling reaction uses the boron as an heteroatom in it for the coupling reaction. Let us see why heterocyclic compounds are important. There are many heterocyclic or heteroatom containing compound in biological system. The most common in DNA and RNA, the nucleic acid are made up of nitrogen containing heteroatom compound. So there are many vitamins and enzymes present in the body which contain the heteroatom in their structure. There are many natural products in nature available which contain the nitrogen, sulfur or oxygen heteroatom in their structure. Even though in hemoglobin, the iron containing ring is acquired by the 4-porphyrin ring, which are 5-membered nitrogen containing heterocycle. Heterocyclic compounds are most important in pharmaceutical application. Generally, most of the drugs or 90% of the drugs contain the heteroatom in its structure. Using these heterocyclic derivatives, there are many active compounds has been prepared such as antimicrobial, anti-cancer, anti-inflammatory, anti-diabetic compound. All these compounds contain the heteroatom in their structure. In agrochemical industry, insecticide and vitamins also contain the heteroatom in their structure. So first of all, we will see the what is the heterocyclic chemistry. Heterocyclic chemistry is a branch of chemistry deals with the synthesis properties and application of heterocycle. So considering the uh, carbocyclic compound, that is cyclopentadiene, one of the carbon is replaced with the oxygen. Give us the heterocyclic oxygen containing 5-membered ring, that is known as the furan. Similarly, one of the carbon in benzene is replaced with the nitrogen, will give the pyridine, which is 6-membered heterocyclic compound. These two are the example of aromatic heterocyclic compound, and another all are the non-aromatic compound. When unsaturated bond are saturated and it's converted to compound number 2, this is the tetrahydrofuran. Similarly, when all the sites of unsaturation pyridine is saturated, it gives the compound number 6, that is pyridine. So in general, the heterocyclic compound are divided into two main classes. The first one is the aromatic and another one is the non-aromatic. Let us see the 3 and 4-membered heterocyclic compound in detail. The above one is the ring size, that is, it is a 3-membered cyclic ring structure. When one of the carbon is replaced with the nitrogen, it gives the azridine. Similarly, it is replaced with oxygen or sulfur, will give oxirane and therane respectively. It is not necessary to only replace one carbon with a heteroatom. We can replace the 2 carbon with a heteroatom, such as diazridine containing 2 nitrogen and dioxirane containing 2 oxygen atom. Even though we can replace one carbon with an oxygen and another carbon and nitrogen, giving rise to 3-membered oxyazridine ring. In 4-member cyclic ring compound, one of the carbon when replaced with the nitrogen will give azetidine, oxetane and theatine when carbon are replaced with oxygen and sulfur respectively. Even though we can replace one of the carbon with silane or phosphane or phosphorus, giving silatane and phosphatane. Let us see the main 5-membered heterocyclic compound. When one of the uh, carbon of cyclopentadiene replaced with the nitrogen will give the pyrrole. When 2 carbon are replaced at 1 and 2 position will give pyrazole. Similarly, 2 carbon at 1 and 3 position are replaced with the nitrogen will give imidazole. When we have the 3 nitrogen containing 5-membered ring, that is termed as the triazole. It can be 1, 2, 3 or 1, 2, 4 triazole. And when 4 carbon are replaced with the nitrogen, that is tetrazole. When we have the benzene ring fused to the pyrrole, will give rise to indole. When we replace the nitrogen or a carbon with the oxygen, will give the furan. These are the 2 heteroatom compounds. There is isoxazole, which has 1,2 substitution. This is oxazole, which has 1,3 substitution containing oxygen and nitrogen, 5-membered ring. Similarly, we can have the trisubstitutate containing 2 nitrogen and oxygen, such as oxadiazole. Similarly, when 1 carbon is replaced with the sulfur, give rise to thiopene. So these are the 5-membered aromatic heterocyclic compound which are common in nature. Let us see the 6-member heterocycle which are more common. When, as I have told earlier, when the carbon is replaced with the nitrogen, we'll give with the pyridine. When we have 2 nitrogen in a ring containing 6-membered ring, such as diene, they are called as in general diene. When we have 1,2 substitution, that is pyridizine. When we have 1,3 substitution, that is pyrimidine. When we have 1,4 substitution, that is pyrazine. Similarly, when 3 carbon are replaced with a nitrogen, that is commonly called as trijane, and when 4 carbon are replaced with the nitrogen, that is known as tetrazine. When we have the benzene ring fused to the pyridine, that is known as quinoline, and the another regioisomer of quinoline is isoquinoline when nitrogen is present at the second position. Least common oxygen containing 6-membered heterocycle is beryllium. There are other some simple heterocyclic compounds also available which are 7-membered in nature. The most common is agipine. And when this agipine is fused to a benzene ring, that is known as benzagipine. There are some other fused bicyclic heterocyclic compound such as 5,5 containing 5,5 ring system, 5,6 ring system and 6,6 ring system. The first example is pyrroline, where we have the nitrogen containing 5,5 membered heterocycle fused together. Another example where we have the 6 plus 5 ring system containing nitrogen, that is indolizine. And this one is the least common, is a quinolizinium, we have in which we have 6 plus 6 fused ring system. Thank you guys. Hope you like my video. Please share and subscribe.